Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So today in this video we will solve one of the important numerical which is based on the composite section here. So already we have solved some of the few problems on the same concept here. Now we will just take one more important problem here. Now in this problem what he has given means, so he has given one composites and concrete column is given. So in that concrete column he has given some like dimensions is given. So the dimensions is of 300 into 300 mm concrete column is given. So in that concrete column, so he has given some steel rods in each corner of 25 mm diameter he has given. So means what, there are four number of steel rods are there which are placed in each corner, whose each and every will be every rod will be having a diameter of 25 mm here. Now again what he has given, the concrete subjected to a stress of 5 Newton per mm square, means what, when we apply load, okay, because of the load here, so this concrete, the stress in the concrete will be a 5 Newton per mm square. Now what will be the corresponding stress in the steel rods, we have to find out. Now he has given one more thing, he has given the relation between the Young's modulus of a steel rod and the concrete he has given in terms of a ratios, that is a ES by EC is equal to 18. Now what we have to find out here is, so we have to find out what will be the stress induced in the steel rod. So to find out the stress induced in the steel rod, the very first thing is what I need to find out what will be the PS here, that is a load which is what will be the load which is there in the steel rod, we have to find out. Now again I have to find out PC is also I have to find out, that is a load in a concrete. So at the last we need to find out what will be the total load. So why we have to find all these parameters, only thing is I have to find out this one, that is a stress induced in the steel rod. Now when we solve such kind of problems like composite sections, we have to consider the two important equation. The thing is what, PS plus PC is equal to P, means what, the total load what we apply, it will be shared by the two materials which is made up of here. So means what, the stress, that is a load of a steel, that is a load in a steel rod plus load which is there in the copper rod, okay, load in the steel rod plus load in the concrete, which gives the total load what will be applied on the concrete member here, okay, concrete structure. Now so this is the one equation, I'll just take this is the equation 1, because we have to consider two important equation. So this is the very first equation. Now the second equation is, so delta LS is equal to delta LC. So what it means, so delta LS means, so it is a change in dimension, change in length in a steel rods and change in length in a change in length in a concrete here. So since it's a concrete structure, it will be both the lengths are same here, okay. So that's why I have taken delta LS is equal to delta LC. Now there is no, because the first equation is all are unknowns, okay, I'll just take as it is here. Now the second equation is, I can just write this equation, okay, delta LS is equal to delta C in a simplest form. So because we know that delta L is nothing but it's a PL by AE. So now since it's a steel, I'll represent with the S here. So again delta L is nothing but it's a PL by AE. So since it's a concrete here, I'll just represent with the C for all other cases. Now so since the length is same, LS is equal to LC, that is the length of the steel rods as well as the length of the concrete in a structure, it is same means, so in this equation we can cancel the LS is equal to LC. Now the remaining terms is what, so PS by AS ES, that is equal to PC AC into EC, okay. So if I find out all these parameters, if I substitute and if I simplify, at the end I am going to get the solution here. Now this is unknown because I cannot change here, okay, I'll just write as it is here. Now after that, so Young's modulus and that is if you just cross multiply this to the right hand side, ES, okay, it becomes PS by AS is equal to PC by AC. So here it's a ES by AC. So means what, this ES by AC I can just simplify, I can write it as a 18 here, okay. So this ES by EC I can write as a directly it's a 18. Now before that, what will be the area in a steel rods? So because since it's a solid part, so the diameter is 25 mm is given. So since the diameter is 25, the area becomes pi d square by 4. Okay, so I just take here area is equal to the pi by 4 into 25 square. This is the cross sectional area for only a single rod, but how many rods will be having here? There are 4 rods in each corner, so I have to multiply here 4 here. Okay, this is the cross sectional, this is the area for the steel rod here. Now 4 get cancelled. If we just simplify, this is the area of a steel rod, so I am getting around 1963.5. This is the area of a steel rod. So what I am getting for all the 4 rods? Oh, that value I can substitute here. Now again I will try to find out what will be the area of a concrete here. Now area of a concrete means, so what I have to take here is, so since it is a square one, that is a 300 into 300, okay, I will get the value of, that is a area of this entire member. But the thing is, I need to find the area of a concrete. I need to find out the area of a concrete here, means out of this 300 into 300, I need to subtract the area of this steel rod here. So I can take this as, this is a 300 into 300. This is the area for entire concrete structure. Out of that, I need to subtract the area of this each steel rod. So means minus of this 1963.5. Now if I simplify, I am going to get a value of area of a concrete only. So it's, I am getting some value around, it's 88036. 88036.5 mm square. So this is what I am getting the area for a concrete here, that is 8806. Okay, so these two areas are important here. Now let us move on to, I will just substitute these two values in this equation here. So what I am getting the value here is PS by, so area of a steel rod is 1963.5, that is equal to PC by, so AC is, so 88036.5 into 18. Now if we just simplify, I am going to get a solution here, that is in terms of PS is equal to, in terms of PC. So that relation what I am getting here is PS is equal to 0.4 times the PC. Okay. So if I just simplify these values, so PS is equal to 0.4 times the PC here. Okay. Now the next thing is what I will go for. Okay. Now what we have to substitute here, if suppose if I take this is the equation 2. If I take this is the equation 2, what I will do here, so just I will substitute the equation 2 in equation 1. I will just substitute the equation 2 in equation 1. I will write here, substitute equation 2 in equation 1. So minus what? So PS means I can write 0.4 PC plus, so this PC it is as it is, that is equal to P here. So this is 1.4 PC is equal to P here. Okay, for time being we just keep as it is here. So what else he has given in this problem is, so stress in the concrete is 5 Newton per mm square. Stress in the concrete is 5 Newton per mm square. We keep this here because we know that stress in a concrete is nothing but it's a load by area. Okay, this is the general standard formula, that is the stress is equal to load by cross sectional area here. Now PC is nothing but it's a unknown. Okay, unknown means, but left hand side part he is given, it's a 5 Newton per mm square. So PC is unknown, but area of a concrete is, it's a 88036.5. So from this if we just simplify, I can get the value of a PC here, that is in terms of kilonewton. So that value what I am getting around is, so PC is equal to 440.18 kilonewton. So when we just simplify here, I am getting the value around, it's a 440.18 kilonewton. Okay, so now I have got this value here. Now you just simplify this PC in this equation somewhere here. Just try to substitute here. I'll get the value of PS. Therefore, PS is equal to 0.4 times the PC. So that is equal to 0.4 times. So PC is nothing but 440.18. So therefore PS, that is 176.07. I'm getting 07 kilonewton. Now what I need to find out here is, so we have to find out sigma S is equal to what? It's a load by area for a steel rod. So PS is nothing but 176.07. So we need, I'll take in terms of the Newton here. So the area of a steel rod is 1963 mm square. Okay, so you just simplify here. I'm going to get somewhere around 89.67 Newton per mm square. So 89.67 Newton per mm square. So even we can calculate what will be the total load in the concrete section here. We suppose if I take PS, P is equal to PS plus PC. So we got the value of P is equal to totally, PS is what? It's a 176.07 kilonewton, and that is the load in the concrete here is, it's a 440.18 kilonewton. Therefore the total load which acts on the concrete section, that is the concrete structure, is, we just add this term here. So we are getting, so 5, so 2, so here it says 6, so 7 plus 4 is 11, 156. So there will be a 616 kilonewton, 616.25 kilonewton will be acting here in the concrete member. So therefore if we just add these two terms, so we are getting a total load which acts on the concrete section, that is the concrete column, is 616.25 kilonewton. I hope you are getting this simple numerical. Please, if you like this video, comment, share it with your friends and subscribe our channel. Thank you.